All right, today we're talking about factoring. So what we're basically doing is we're going in the opposite direction of what we were just doing. Okay, so starting with factoring, the greatest common factor is the basic level of factoring, and you probably already know, kind of what to do with this. You've done this before. So if we had something like 4x squared minus 3x. So we're going to factor out the greatest common factor here. So I like to start with the numbers. Is there a common factor between 4 and 3 besides 1? No. Right? Every one of the numbers will always have a common 1. But that doesn't help us because if I factor or divide out a 1, it doesn't change the number, right? So what about the variables? Is there an x term in both of them? Is there an x squared in both? No. There is at least an x, but there's not an x squared because this is just to the first power. So in this case, my common factor is x. So if I pull it out, I'm going to divide it out of each term. All right, so there's two ways that I think are easy to think about this. Either I'm dividing it out, or I can think in reverse distributive property, kind of is the way I like to explain it some. What would I multiply x by here to end up with 4x squared? 4x, right? And then what would I multiply x by to get negative 3x? Just negative 3. So that's what I mean by it's like a reverse distributive property. And you guys have all done that before probably, right? To a certain extent. All right, well, what if we had something like this? 10y cubed plus 20y squared minus 5y. So look at the numbers. What's the common factor between the numbers? 5. And then is there a y in each term? All right, yes. Is there a y squared in each term? No, right? So of course, if there's not a y squared, then there's not at least a y cubed. So there is a y in every one of those terms. So we can factor it out. What would I multiply 5y to get 10y cubed? 2y squared, right? How would I get to 20y squared if I'm multiplying it by 5y? Good. And then 5y to get to negative 5y, what would I do? Negative 1. So anything times negative 1 doesn't change the value. Okay, so greatest common factor, you had to have done some type of factoring like that before in middle school or integrated 1. And that should be a little bit of review, but if you've never seen it, you can kind of pick up on it and see what we're doing. That's the very basic level of factoring. Now, what we're really going to focus on today is factoring quadratics or a quadratic trinomial. Okay, and what we want to do is we want to go in reverse. So I want you to multiply this. How are we going to multiply that? What are we going to have to use? FOIL, right? Or the distributive property twice. It's the same thing. So go ahead and do that real quick. All right, so you started with first, and you got x squared, right? And then you did outer, and you got plus 5x. And then you did inner, and you got plus 2x. And then you last, and we got plus 10, right? So then hopefully you simplify and got 7x plus 10. No. Why not? What are we doing there? We're adding, right? So remember we said when we're adding, we're never going to change our exponent. It's just a collection of like terms, right? So we got to be careful there. So what we're going to do today is we're going to start from here. And we're going to change it back to this. Okay? So the standard form for a quadratic is written like this: ax squared plus bx plus c, where a and b are our coefficients in front of those variables, okay? So, and then c is our constant at the end. So if I reference a, b, or c, this is what I'm talking about. So in this one that we just multiplied, what is a? So remember, it's a coefficient, so what number's in front of that x squared? It's a 1. I heard it mixed in, but I heard some other answers too. So if there's nothing there, there's a 1 there, right? It's an understood 1. What is our b term? 7, and then our c term is 10. Okay? So what we need to change our thinking to do is kind of think about, and the reason why I had you multiply this together, because I want you to have this fresh on your mind. How did we get from here to here when we FOILed, right? And what happened, what's going on? So we start with this number, this c. Okay, now how did we get 10? 5 times 2, right? And then my answer was positive. Why? Because I multiplied positive 2 times positive 5, right? How else could that 10 have been positive? Negative 2 times negative 5, right? So as long as they were both the same sign, I'm always going to end up with a plus here. So that's kind of one of our starting rules. If that's a plus, then we know that these two signs were the same. How could I end up with a negative c there? If one's plus and one's minus, right? So if I end up with a negative, then I'm going to have different signs. So that c term right there tells us quite a bit about what the middle part is of the two binomials is going to look like, right? Now, how did I end up getting this 7, this b term? I added the inside terms together, right? So that b term is going to be the result of me adding those two outer and inner terms together. We're going to use that in a second, okay? So let's start, and we'll just kind of think through one. And as we get a couple of these, I think you'll start to see the process. So our goal is to factor this. So every time we're going to start with a greatest common factor. That should always be your first thought. Is there a greatest common factor here? There's a 2 here? No, right? That's a 1 right there. So 1, 6, and 8, the only number that they have in common is 1. And that doesn't help us. If I factor out a 1, it's not changing anything. Is there an x in all 3 terms? No. So there's not always going to be a greatest common factor. But you have to start thinking that, because if there is, we have to pull it out, and we'll do that later. But for right now, everything that we're talking about is going to happen when a is 1. If a is a different number, it changes this a little bit, and then we'll look at that too. But for now, for today, a is going to be 1 on all of these that we try. Okay? So here's how I start the problem. I'm thinking about this c term. and it tells us a lot. Well, before that, let me back up a little bit. Let's start here. If A is 1, all I have is x and x. Okay, so that's the really beginning. But now I'm going to start looking at this C term, because this is where it's going to tell me a lot more about this problem. I ended up with positive 8. So that means that because C was positive, I'm going to use the same sign. So now I know it's going to be plus plus or minus minus. Yes. That's exactly right. So now, once we've determined they're going to be the same, I can look over here and find out which one I'm using. So think about that. If I added two numbers together and I ended up with a positive 6, and they were the same sign, I can't add a negative and a negative together and get a positive 6, right? So anytime you're using the same sign, all you have to do is look over to the B term, and that one will tell you which one we're going to use. So we know it's plus plus here. Now, how did we get 8? We multiplied, right? So what numbers multiply to give us 8? 4 and 2 and 8 and 1. So now, because A is 1, it's as simple as this. Which pair of these numbers adds together to give us 6? 4 and 2. And then we've just factored that. How could I check my work? I could FOIL it back out, right? Now, let me ask you a question. Well, let's just FOIL it out, and then I'll ask the question. First, x squared. Outer, positive 2x. Inner, positive 4x. And then last, positive 8. So x squared plus 6x plus 8. Is that what we were looking for? Yeah, so we know we're correct. So let me ask you this. I had A is 1, so all I needed that to be was x squared. Can I mess that up when A is 1? It's always just going to be x and x or y and y, whatever variable you're using. So it's not a big deal there. Our mistake is not going to be here. What about with the 8? We specifically picked these two sets of numbers because I wanted them to multiply to be 8. So we picked 4 and 2 to know that that was going to be 8. Probably not going to have our mistake right there. So that means where's our mistake going to happen if we have one? It's going to be in this B term. So I always tell my students, like, once we get a little bit better at this, really the only thing that we need to check is the outer and inner. We need to make sure that these combine to give us that B that we're looking for. Okay? Because we picked the numbers to give us x squared. We picked the numbers to give us 8. What we're looking for is to make sure is that middle term combines to give us what we need. Okay? The other question that I always get right here, well, what if I wrote 2 right there and 4 right there? Is that still okay? Does that change anything? No, it won't change anything. Okay? The only time you really have to be careful is when we have different signs, one's plus and one's minus, then it does matter. Okay, so and we'll look at that in a second. Any questions over that before we move on to another one? X squared minus 10x plus 16. So we're going to factor this. Does it have a greatest common factor? No. Okay, but we always have to start there. Okay, so now because A is 1, I can start with my x and x. Now what does the C term tell me? That they're going to be the same sign. But what does the B term tell me? They're both going to be minus. Very good. So negative, negative there, and we are almost finished with this problem. Now, what are our pairs that multiply to give us 16? 4 and 4, 8 and 2, 16 and 1, right? This is the one that people always forget about. It's always going to be the number in 1, and sometimes that's what we need. But which one of these add together to give us 10? It's the 8 and 2. Does it matter where I write them? No, because they're both minus, right? So we've just factored that one. Not that bad, right? So check it, but let's just check what we need to check. We know the x squared is going to work. We know the 16 is going to work because we picked those numbers to give us those products. But we need to check our outer and inner. So outer is negative 2x. The inner is negative 8x. Does that add together to give us negative 10? Yeah, negative 10x. So we're good. I guess I should put my check mark here, right? Any questions over that one? Nothing different when it's minus minus, right? It's kind of the same thing, but we're going to use a negative sign. So now last, what is the last situation we haven't looked at yet? C being negative, right? X squared minus 5x minus 24. For now, for today, yes. But we could have 3x squared, we could have 5x squared. So good question. But for right now, yes, we're just starting at the beginning, and then we'll add that in because that changes how we think a little bit. Okay, so good question. All right, so is there a greatest common factor? No. So we can start with x and x. The signs are different. So one is going to be plus and one's going to be minus. So now, before we get into like the pairs that multiply to give us 24, I want us to think about what happens when I have a plus and a minus sign. So let's just side work, nothing to do with this problem, just some thought, some food for thought. What if I had negative 7x and positive 3x? What do I end up with as an answer? Negative 4x. What really happened between the 7 and, forget about the negative, what did we do between the 7 and the 3? We kind of subtracted, right? And the way I was taught this was whenever you're doing negatives and positives, you subtract the two numbers and keep the sign of the larger number. I don't know how, there's a million ways to teach this. But I always thought of it that way. Subtract the two numbers, and then since the 7 is bigger than the 3, not talking about the negatives, but we'll keep that sign. So let's just look at the same two numbers. What happens if we go that way? I end up with a positive 4x, right? So thinking like this, if I'm going to combine my outer and inner terms and my answer ends up being negative 5, what has to be true? Very good. The bigger number has to be negative in this case, right? So this is how I think about this. What numbers multiply to give us 24, negative 24? 8 and 3, 6 and 4, 12 and 2. I don't know what I was writing. And 24 and 1, right? So now, these are all the possible numbers we could fill in here. Which of those subtract to give us negative 5? 8 and 3. But if it's negative 5, which one has to be negative? The 8. So when I'm doing these problems, this tells me everything almost I need to know, right? At least to start. Same signs or different signs? Well, they're different signs. So now I immediately look and say, okay, I know the bigger number has to be negative. And when I say that, somebody always says, well, negative 8 is not bigger than 3. It's not, you're right. But I'm talking about just 8, just 3. So in that way, when I subtract, which sign would carry, or really when I combine them, which sign was going to, carry on with that. So now this one for sure is one that we would want to check. I know my x squared is going to work. I know my negative 24 is going to work. But I want to make sure that my outer and inner are going to give us negative 5. So outer, negative 8x, inner, plus 3x, and that gives me negative 5x, and that's exactly what we wanted, right? So in general, for your notes, if I have x squared plus, I'm going to write it like this. I'll put the a in there. It's going to be what? What are my signs? Plus, plus, right? What if I have ax squared minus bx plus c? Excuse me, minus, thinking ahead. Same sign still, but they're both going to be minus. And then, struggling a little bit. Ax, and I'm going to write it like this, plus or minus, because it doesn't matter there, right? I mean, it matters, it changes the problem a little bit, but for what we're trying to do here, we're going to have 1 plus and 1 minus, right? So depending on whether that's positive or negative is going to change which bigger number we pair with that sign. Okay? Is there any questions? Are there any questions on Zoom? All right, well, let me give you a couple to try. We'll do one, we'll come back together, and then we'll do another one. All right, let's save that. Sorry, I want to do that one next. Minus 11x plus 24. All right, is there a greatest common factor? So did you start with x and x? So now what does the C term tell me? Same signs, and they are both going to be negative, right? So now what numbers multiply to give us 24, but also add together to give us negative 11? 8 and 30. Did you check your work? All right. 2x, or excuse me, x squared plus 2x minus 15. All right. Is there a greatest common factor? No. And I know it's annoying that I keep saying that, but it's important because later on, as we get more complicated polynomials that we're trying to factor, that will be, come into play. So signs are different, and the bigger number needs to be positive. So what two numbers multiply to give us 15, but we'll subtract and give us positive 2? And then which one's here? 5 and 3. Okay. So what we're going to do in class is we're going to work on our assignment that's paired with this. Same thing with Zoom. You guys, distance learners, need to access that through Kidem, and it will be the factoring 1. And then there'll be a second lesson that will come along that will give us how to do the factoring 2, and then we'll go from there. So you guys can ask any questions or let me know then. So is everybody good in class and on Zoom? Okay. Thanks, guys.